Hello everyone, we're going to solve electric potential, work done, and also electric potential energy. So are you ready? Let's go. Here I have R1 and R2 in blue ink, and this one I have R1 and R2 in green ink. We're going to use the blue ink to find the VA and the green ink to find the VB. But before we go any further, remember this. Do not include the positive and negative sign if you want to solve F and E questions. To solve V and U problems, it is a must for you to include the positive and negative sign in your substitution. Now let's continue. To get the electric potential felt at point E, VA equals to V1 plus V2, KQ1 over R1 plus KQ2 over R2. Here I factorize the K, 9 times 10 to the power of 9, and then I substitute the value of Q1 and R1 plus negative. You see here, I put the negative sign into the substitution. And finally, the value of VA is negative 737 volt. Now let's find the electric potential at point B. VB equals to V1 plus V2, KQ1 over R1 plus KQ2 over R2. Again, I factorize the value of K. And for the magnitude of the charge, I don't put the symbol nano in the substitution. Instead, I put to the power of negative 9. And don't forget to put the negative sign for the charge Q2. And finally, the electric potential felt at point B is negative 704 volt. For question C, we are given this external charge, and we name it as Q. And we have to move it from point A to point B. And now we have to find the work done. And since we already got the electric potential at point A and B, work done to bring a charge from point A to point B is delta VBA times the charge. Electric potential at point B minus electric potential at point A times the charge. We substitute all the values, and remember, you have to include all the signs. Thus, the work done is negative 8.25 to the power of negative 8 joule. The last question is asking for potential energy for the whole system when we add another charge at point B. We call this new charge as Q3. Now let's put this Q3 into the system. So to answer this question, we have to find the energy between Q1 and Q2, and we name it as U12. Next, the energy between Q2 and Q3, U23, and the last one, U13. So the total electric potential energy for the whole system is U12 plus U23 plus U31. We add in the electric potential energy formula, KQ1Q2 over R12 plus KQ2Q3 over R23 plus KQ3Q1 over R31. I factorize the K and substitute all the values including the signs. And the final answer is negative 3.52 to the power of negative 16 joule. That's all. Thank you everyone.